Hello everybody, welcome to this new live stream. In fact, this is the 10th live stream in which we are creating a game in C from scratch. If you watched from the first live stream all the way to this one, you've seen the whole process of us creating a pretty cool game. We started out as a breakout clone, but we slowly started to implement more gameplay stuff, gameplay ideas, as well as the fundamental level systems that we need in order to create that. So, first of all, let me show you what we have now in this series of live streams. This is the point which we have so far. So we start out at this breakout game, and we added, improved the gameplay in the last couple streams. And the last stream, we actually inserted support for rotated rectangles. So if you can see, when we destroy the block, the particles actually have random rotations to them, and the trail actually has a pretty cool random rotation. And then we have like more game modes, which has like power-ups and power-downs. And yeah, let's see if we can get like a power-up. Yeah, like this. Let's see. Yeah, see? So that's the state of the game so far. I think it's pretty cool. I think we are actually getting somewhere pretty nice. In this past stream, and we're also going to do that today, we're going to improve on the engine so we can do more stuff. So if you can see, the power-ups and the power-downs are just squares. See? They're just colored squares. What I want to do now is actually make them bitmaps. So the player will know what is the power-up and what is the power-down. So he can make more informed decision on whether or not he will try to get that or try to avoid that. So that is the basic idea, to implement bitmap support in our engine. If you go to the YouTube page, you can see all those streams that I talked about, all the 9 of them that I already posted, and this one's the 10th. So you can watch all of them in sequence and see from the very first line of code that we wrote all the way to the point at we are now. And you can also go to the itch.io page, and here you can download the game and the source code. So you can see a couple of cool GIFs, and then you can download. Each day has a separate executable and source code. So you can download to see what the game is at this point, and download source code to play around and improve and change and do whatever you want with the source code, and learn too. That's one of the big points. Okay, so in order to start implementing bitmaps, I'm going to first create a bitmap, right? That's kind of necessary. I'm going to do like a very quick a programmer art kind of bitmap, just so we can. I'll do an 8x8 pixel art. Yeah, just so we can start playing around with that. Let's make start with the yellow. A yellow power-up. Okay. Hey, Muji Ghost, dude, nice to see you here. Finally, right? Although I think you have watched a couple of streams, right? Today we're going to implement bitmap support to our engine. Dude, it's nice to see you. You have to hang out sometimes, right? Okay, so let's do this is the invincibility power-up. I'm going to do that on another layer. Okay, but let's also know which way is up, and that's like a pure green and a pure blue. Oh, actually, that wasn't a pure green. Just so we know which way is up and which way is down on our bitmap, because we probably got that wrong the first time. Yesterday I watched. That was pretty cool, man. Yesterday we kind of stumbled upon a lot of problems. We did rotated rects, but today, I don't know, I think I'm pretty confident into what we're going to do today. So I'm going to create a data folder inside our directory, and I'm going to have the power up invincibility.png. So the first thing we're going to do is actually read this file. And so in the Windows platform layer, I'm going to create a function. I'm going to comment is like file IO. We're going to do file writing later on. And okay, so the basic idea is we're going to pass like a void star. Let's call that OS read entire file. And we need to get the file memory and the file size. I think I'm going to create a string data structure in the code. I think I'm going to do like a string.c, just so we can consider our bitmaps, our files just as strings. Because in fact, what is a string? All we're going to do, for now at least, is going to, let's say we have a character pointer called data, and a signed 64-bit for the size. So that's what we have for our string, right? And then let's include these guys, maybe up here at the top. String.c, okay? And then I'm going to do like an internal string, result. Okay, that's the basic idea. Now we have to fill this guy, and the calls that we want are actually like create file to get the file handle. Create file A. Let's do like, yeah, this guy. We can do like create file, and we can also do, yeah, let's start with this one. And then we have is that a read file? MSDN? Yes, in read file. Because this one takes a file handle. So we use create file to create the file handle. And then we can read that file when we got it. Okay? So I'm going to initialize this guy to 0. And then, okay, so the file path, desired access, let's see, generic read, share mode. Let's do file share read so other people can read this file as well. Security attributes. I don't think we care about this at all, so creation disposition. I think I'm going to try to do open existing, so we're going to have like an invalid handle if we don't have the file. Flags and attributes. Let's see. I don't think we care about any of this. Yeah. And a template file, I don't think we need that. Okay. I'm thinking on start watching Handmade Heroes. Dude, Handmade Hero is really cool. It's what actually made me want to start programming for real. For those who don't know, Handmade Hero, which is handmadehero.org, is a series by one of the best programmers I have ever seen, which is Casey Muratori. His code, he wrote like a animation system, which is like Granny 3D. And this animation system that he wrote is in over 4,800 games. And you know, pretty small games, like, I don't know, Activision used it. Like, let's see, Bungie used it for Destiny. I don't know if you guys, and EVE Online, that's like a pretty small game, right? And yeah, another couple of small studios like Disney and Electronic Arts use it for The Sims. So yeah, and he is creating, which is not done yet, he's creating a series of live streams as well, where he's creating a game and engine from scratch. But he's doing like a very complete, yeah, Destiny pretty small, yeah, just very small games. He used his library, and it's pretty cool because the guy who wrote Game Engine Architecture, let's see, Game Engine Architecture, which is one of the engine leads at Naughty Dog, actually commented on the book that Granny was the best library that he had ever used. And this guy probably used a lot of libraries. So, yeah, this guy who works on this small game as well. Yeah, and so Casey does these streams, and he starts out from scratch, and he goes pretty much like from everything you can ever possibly want from a game. He starts out pretty simple, like 2D tile map based. Then he starts doing like optimizations in 3D and lighting, pretty advanced global illuminations, things like that. And I pretty much think it's going to go into gameplay. But since he's an engine programmer, he focuses a lot more on the engine. And in this case, which is to answer Bial's question, what am I doing? We are creating a game in C from scratch. So this is the game that we have so far. This is the 10th live stream. And we started out with a breakout clone, right? So breakout, and then we start doing some crazy ideas with breakout. Like this is Pong, but as a breakout game. So let's see. Yeah. Let's try to get the ball behind. Okay, then we also have Space Invaders. How do you speak English so good? I don't know, man. I just listen to a lot of stuff and also practice. And this live stream is actually making my English a lot better, so that's also that. Okay, yeah, we got a frame rate drop, pretty big one there. We're gonna have to optimize that later on. So this is the game that we're building, but our scope is way smaller than Casey's, so I think that's the main advantage. We want to release this game pretty quickly. I'd say I'm going to guess that we're going to go up to 25 episodes, and this is the 10th episode. So I'm estimating that we have 16 more episodes, counting with this one, right? And but him and Hero, like he has a lot of experience. He has been programming games ever since before I was born, actually. So he knows his stuff, this guy, and he goes to really advanced topics. And I really suggest that anyone who wants to know more about programming in general, especially like game engine programming, should really watch that. But in our case, we are now doing our file stuff. So we should be able to create a file, right? And let's do like file handle. Okay, if the file handle is a invalid handle, let me see in the documentations. Return value. Let's see. Invalid. Is it not invalid? Oh, okay, no, I'm in create file. Okay. Invalid handle value. Okay, so if it's invalid, all we're going to do now is actually assert, and then we're going to return result, but we want to actually like a complete error message. I don't know, maybe we should just crash at this point. I'm too surprised how much we already improved since that cow game jam. Yeah, and it's been like 1.5 years, and it was a lot, you know. I think you remember on that game jam that we were doing. I was trying to do bitmap, and I like the whole night, spent one night doing bitmaps. Today we're gonna do bitmaps. So I think this is actually my real test to see how much I improved since last time. Let's see how difficult it's gonna be to do bitmaps, and it's gonna be pixel independent bitmaps, so it's a little bit harder. Okay, so if the handle is not valid, now we can possibly read file. I think we're gonna get the file size. Bytes read, bytes to read. Yeah, we also need a file size, so let me just copy this guy. And let's do like MSDN file size. We're gonna nail it, I believe. I hope so. I think this is not gonna be that hard. I don't know. Famous last words, right? So the file size returns a pointer to the variable where the high order is returned. Can be null. I don't think we're gonna use like double word, which is like for 64-bit file sizes. Yeah, let's do like the word file size. I'm gonna have to step through that. Let's see, this is the file handle, and this is, let's just pass 0. Okay, file handle. The buffer we have, oh, then we have to allocate that, right? So we're going to do result.size equals file size, and result equals data equals, let's do the virtual alloc call. And since we're going to have like, probably going to pack this up to a single file, I don't think we care that we allocate at this point. So yeah, it's just we're not going to use like more complicated memory allocation stuff. So let's just do the result dot size. Okay, now the file handle, the buffer result dot data, number of bytes to read, let's do file size, number of bytes read, let's call that bytes read, and overlapped, I don't think we care about that. Yeah, we don't care about that. Okay, now possibly we succeeded. Now I have to test like if this succeeds and the file size, and the file size is equal to the bytes read, right? Like, we should also like, yeah, let's do it like this, okay? And if we succeed, we are going to, yeah, let's do like success. Yeah, that's about it. Bytes read, let's do a keyword. Bytes read. Okay, now, first of all, let's call this guy, right? So in the initialized, when we initialize, we are going to, like image, we're going to OS read entire file, we're going to go to data slash power up, I don't know what I call the image. Let's see, power up. Power up invincibility. Okay. .png. Now, okay. Now we have to forward declare this guy, and I think I'm going to do that on the platform common. So like platform services to the game. So far we only care about this guy. Okay. Now let's debug and see if we get the file. Okay. Let's see, file path. This looks correct. Oh, we have to run from the correct path now. Now, we are running from the default path, which is the build folder. I'm going to run from the root folder, so I'm going to ignore that build thing. Okay, now let's go back and try to read this guy. So do we have a valid handle? Looks like a valid one. Okay, the file size is 450. Let's see if that makes sense. That is perfect. So we allocate 450 bytes. And okay, so we read successfully. Okay, so our data shows our PNG file. Let's see here. See, so it has the PNG magic word and all sorts of crazy stuff. And then, I don't know if, yeah. You said in the first episode, it's very much true, watching this and think, man, I don't know how to code. Yeah, you're talking about Handmade Hero, I suppose, right? Yeah, man, I mean, it's really hard when you actually, tell the computer what to do if you haven't done that before. So, but it's a great learning exercise. So, and it's only been like, I don't know, 2 years since I started programming for real. I mean, I started doing that when I released Eliosa's Hunt, and that was like pretty much 2 years. Next month's gonna be 2 years that we released Eliosa's Hunt. So when we released the game, I was like, okay, I don't know how to code. I have to learn that. That's where I started for real learning. And I've done a lot of cool projects. I can show you a lot of cool projects that I did to learn. And I can I'm pretty comfortable now doing this kind of stuff. But I want to do like more and more complex games, especially like lower level engine stuff. Maybe when I finish this game, I'm going to do like a more robust engine with like OpenGL and shaders and multi-platform with Linux support and I don't know, online subsystems stuff. That could be cool. Which editor IDE would we recommend? Well, I really like 4Coder, so I do recommend it. You can download it for free on itch.io, like 4Coder. itch.io. There is a paid version, which is like $12. If you want to get the customization layer, hell, you code in Vim. No, that's not Vim. You're talking about me? That's not Vim. That's FarCoder, this guy. And I really like FarCoder. And you can download the free version here, the demo. But I compile and debug on Visual Studio. Okay, so we are reading the file. Now, what we want to do now is convert this guy, which is compressed in a PNG kind of way, to our format, which is basically going to be uncompressed because we have to read each pixel, right? So for that, I'm going to use Sean Barrett's awesome STB image. If you guys don't know Sean Barrett, he was the graphics programmer for the engine for the very first Thief game. You're talking about the very first one, when people didn't know how to do 3D that well. He was the main graphics guy exploring the 3D territory at that point in time. So he's the real deal. And he created all these cool libraries that we can use. It's in the public domain. And one of them is STB image. It's a single file library like this. And it's pretty easy to use. Really easy to use. I'm going to use that now. Cool, I'm learning C and using VS Code for the moment. I'll try FarCoder. Yeah, I think VS Code has too much if you're programming like lower level stuff. Like if you do like JavaScript or PHP or I don't know, Python, that's great, I think. But for lower level stuff, I don't really like it. I use it when I do Morpheus says 7,000 lines of code and easy to use. Well, let's see. He knows how to do it, and now he works at Red Game Tools. Red Game Tools is the company that when I talked about Casey released that the Granny library, right? Granny 3D when he was working at Red. And Red releases pretty much all the tools that most game engines use. So Bing Video, you can pretty much make sure that all AAA games that use a video, which is like all of them, use Bing Video. It's like the best video library ever. And they also have like this awesome, I haven't used any of this just for disclaimer because it's pretty expensive. They also have like awesome formats and they have like all this stuff. And Sean works at Red, and the point of Red is to make not only to make awesome libraries, but to be very easy to use. Let's see, Morpheus, how easy to use is this library. So I'm going to copy this. I'm going to create stbimage.h. Okay, this is the library. Up top, we can see a couple of like release notes, and it already tells how we should do. Like, do this before you include this file. It should look like this. Okay, so this is how we're going to do it. See, this is how we implement, and now we compile. Okay. I think they already have an assert. No, this is just a warning. Expression is always true. So I can either delete that or just remove the warning. I think I'm going to remove the warning because warnings are not errors. Okay, so now we have the library. Let's go back to the top and see how should we use it. Okay, so here are the image formats. Do you recommend any source to improve the process of learning C? I'm going to have C in my next term in college, but I'd like to start the course in some good knowledge in advance. Well, it depends. Do you have like prior knowledge of programming? I suppose you do, right? If you do have a little bit of knowledge in programming, I recommend like Handmade Heroes Introduction to C. If you go like to handmadehero.org, you can go like watch, and then you have here Intro to C. I mean, it's not like a very easy, to be honest. I'm going to throw the link on the chat. It's pretty advanced. So you gotta have prior knowledge of programming, but he's gonna talk about everything you need to know to get started, like everything. And then I suggest you just go ahead and watch my series from the very start, and his series as well. Yeah, Java Node. Yeah, I think you can pretty much handle that. It's gonna be pretty cool. And then you can watch my series and his series as well. My series are pretty short, so the C programming language. Yeah, so Morpheus gives a nice reference in case you want to learn C. But I do intend to do some like tutorials, beginner tutorials as well. Tulinho says, "What's up, man? Long time no see, dude. We have to do like a meeting, right? To get everyone together and talk about what everyone's been doing. So yeah, it's been a long time actually. Yeah, I mean, you guys graduated when? It was like 1.5 years ago, I think, already. I don't know. That's pretty cool. Okay, so let's see, documentation. So it talks about the limits, and but here is how we're going to use the library. Yeah, I can configure that. Primary API works on all images of all type. So this is the primary API. All you have to do is like load SBI load from memory. I'm not sure. No, that's not correct. Like yeah, I kind of skipped that, I suppose. Let's go. Let's see. Yeah, I kind of know how to use it, but I'm just going to show you guys. Okay, so basic usage. This is the basic usage. So yeah. So this is how you use it, Morpheus. You call SCBI load, and you pass the file name and the pointers to the X, Y, and the number of bits. Yeah. And then if you need a specific number of bits, and then they return to you the memory uncompressed. So that's the basic usage, and then you can free later on, but we're not going to free. So that's how we do it. But instead of passing the file name, since we already read the file here, we can go ahead in our game and do STBI load from memory, which is the same thing, right? So let's see, yeah. Same thing, I'm going to say, where are we reading from? So we're reading from image.data. We have like the image.size. And then I'm going to pass an X, pass a Y, pass a number of channels in the file. But we do need 4 bytes per channel. So we're going to pass 4 here. These are channels. Okay, and this should return actually our, let's call them like U32 pixels. This should be our actual pixels, if we are not very much mistaken. And we're going to do int x, y, and n. Okay, let's see. Function difference from char. This guy, I suppose. I think they expect a. Yeah, let's guess the void star. Conversion from very big to int. I don't remember having to do all these casts, so let's go ahead and see the documentation again. Load and free. Okay, but we can also do. Okay, let's see. Yeah, I think that's it. Load from memory. Yeah, I'm just going to cast. It's okay. So we cast a void star, then we cast to U32, and this guy, since we read in 32-bit, we can pretty much just cast to int. Have you already done the threading stuff? No, we are really close to doing this threading stuff, Morpheus. The plan is, today we're going to pretty much do these two, bitmaps and subpixel accurate rendering. So next time, we're going to do, let's see, we're going to do audio, and then the other one we're going to do threading. So I think it's going to be on the episode 12. So like 2 episodes from now. Then we're going to do threading. It's going to be so easy, you're going to be disappointed. So don't get your hopes too high. It's pretty easy to get what we're going to do like a simple job system for the render, and we're going to do like the whole audio threaded. Why don't you have notifications on your stream? Don't I have notifications? I thought I did, but I don't know how this works. I should probably check that. How do you know the date and time when you're going to stream it? Okay, let me do like an estimate. So today's Friday. If we manage to get these 2 today, which I think we're going to do, it's pretty early still. If we manage to do these 2, I'm going to do another stream maybe tomorrow afternoon. I mean, today, it's like 7 o'clock here in Brazil. So approximately like 4 o'clock I might do a stream. That's going to be audio. So threading should be like Sunday morning, I suppose, or Sunday afternoon. I think Sunday morning is better. So Sunday morning, Sunday, like around 9 or 10 a.m. BRT. So you can, yeah, probably. If you need any help setting up Twitch stuff like notifications, you can call me later. Dude, I think I'm gonna need that because we've been doing this for way longer than I have. I just started like last week, and I still don't know all these things. So Sunday sounds good. Yeah, I think we're gonna get to that Sunday. Okay, so STDI. Well, let's see if we do have our image now in memory, right? So let's go back to the result. Okay. Oh, we go out of scope. Well, let's see if we still have the pixels here. Dude, there's so much stuff from Visual Studio. Yeah, we don't have the pixels. So I have to do like the trick, just to do like, just so we can debug from here. I'm also my third streamer year? Dude. Yeah, I've watched a couple of streams, like the Spider-Man series you did. That's pretty cool. Okay, so let's see. These are our pixels. Let's compare that to what we think our pixels are. So we have 0, 0, full, full. This is our first pixel, which is blue. That looks pretty correct to me. Then we have 0, full, 0, full. This is green. Then we have like yellow repeated. Yeah, this is yellow. This is yellow. This looks perfect. But there's a small problem. This is perfect, but we are top down. Our render probably is going to be bottom up. I mean, it doesn't really matter, but I think it's going to be easier because we can set like the pixels here and then just increment the way we're doing. So I'm going to pass a, I don't know, bottom. Let's see if it has like a bottom up or top down. Yeah. There's no padding. They do have a helper function that we can set, or we can do like ourselves to do like revert, like inverse. Yeah, let me just cheat and look at another code base. I don't remember where this is going to be, like STDI. No, it's not in assets. Maybe it's in OpenGL? Yeah, it's OpenGL. Flip vertically. Okay. So we are going to set it to flip vertically, and then we're going to set it. Okay. So now if we run, we shouldn't have actually. We should be yellow. We should have like this guy first. Let's see. Our pixels are these guys, and yeah, we start with yellow. Okay, nice. Now let's do our actual routine to draw. So in the renderer, software renderer, we are going to, I think we can delete these guys. Draw transparent, rect in pixels, and the other transparent one. Yeah, because we did the rotated and transparent guy. Yeah, okay. So internal void draw bitmap. That's pretty cool, right? We need, let's do like a bitmap struct. We're gonna receive a bitmap, and then a p, a half size. Let's do just this for now. Then we can get like a color later on and do some blending. Okay? Okay, now let's specify, let's do like bitmaps. Let's do our struct bitmap. All we need now is the pixels. And let's do like X and Y. Yeah, okay. So we have a pointer to a bitmap. And all we're going to do here, we're going to do like the for, yeah, we're going to do the same thing we do in the draw rect, this guy. And we're not going to do like rotation or anything. as a start, and then later on we can add to our routine. Okay, so this is what we have. We don't have a color. We're going to do like let's do black. Well, let's do blue. Okay, now in the game, I'm going to do like a bitmap. Then we're going to do bitmap dot pixels. It's going to be this guy, and then this guy is going to be the pointer to bitmap dot x, bitmap dot y. Yeah, that's it. And then here we're going to do the draw bitmap. We're going to pass the bitmap pointer to the bitmap, and let's see, we are at 0, 0. I'm going to do 10, 10. You're using Vim commands? Dude, it's not Vim. I think you're just trolling by now. Yeah. Okay, so we do have a blue guy. So the challenge, and now you guys should pay attention because this is going to be, as we say in Brazil, the cat's jump, right? This is the important part. If you get this, the rest is going to be pretty easy. So I also have to make sure that I get this. We need to get the color, right? And let's say we're drawing like this guy. Let's say our bitmap is this small guy. We need to know in a relative coordinate system, which is called UV, which is like 0, 1, and 1. In this relative coordinate system, relative to the size, right? We need to know where we are here and where we want to get the guy here. So if we are like on the very first pixel, this should be 0, and if we are in the last one, this should be 1. And if you do have this number, we can just go to this guy and then see, let's say it's 8 by 8, right? So 1 should be the 8th pixel, and 0 should be the 0th pixel, and then everything in between. So this is the idea. We need to get this number, and then we just lerp to get the texture. Then we can do like some more advanced sampling later on. Okay, that's the basic idea that we're going to do. So, okay. We start at this guy, right? I think we already have that function in our math library, which is a map into range. We have that. I think it's just going to call that. I think. So if you do like, let's call that, that's the U, right? It's going to do the map into range for this guy, the X. X0 is the min. We are the X, and then we have X1, which is the max. We have to make these guys all F32s. Okay, so this guy should give us where we are at 0 to 1 on our target square, this guy. And all we want to do now is to lerp to get where we want to be in our relative square, our source square, which is this guy, right? And we have to do the same thing for the y. I think I can do this out here, y1. Okay, I'll call that v. Let's just see if we're not like stupidly wrong. So I'm gonna go inside the draw bitmap call, and let's see in our first call, u is 0 and v is 0. That sounds about right. Now we're moving a little bit to the side here in the u. See? This looks pretty correct. So now that we do have the u and the v, all we have to do is to fetch bitmap, right? So if we have the pixel, which is the bitmap pixels, and we have to set the color, right? Color is going to be bitmap pixels. That's U32, correct? And in fact, just so we can do like very slowly, if we do this, we should be all yellow, which is I'm just getting the first pixel. Yeah. Let's see if we have a yellow guy. No, no, this is unexpected. Yeah. Let's see. Oh, maybe our pixel format is different. I'm not sure. Let's see. We have FF0000F. This should be yellow. Let's see in hex what our colors are. That's weird. The color that we got from this guy was so totally not correct. Where are you from? I'm from Brazil. Well, I think is that we may have to switch our RGB to be BGR, I think. But let's just not worry about that, and let's see what we have for our image. Okay, now we're not going to fetch the first one. We have to add an X and a Y times the bitmap. Yeah, we have to know, like, let's call that UI, and we have to add like a VI, which is times the bitmap width. Okay. How your English is crazy good. Prazer. Prazer, dude. Where are you from? We're in Brazil. I'm here in Belo Horizonte. I have a very strong accent from Minas Gerais. My Portuguese accent. Everyone, when I travel around Brazil with our game, Iliosa's Hunt, everyone could tell right off the bat where I was from here in Brazil. Okay, so we have to see where our U pixel is. I should call it that, like a pixel X and our pixel Y. Yeah, pixel X plus pixel Y. Brazil too. I'm living in Canada. Dude, that's awesome. That's pretty cool. Do you have like are you working with development there at Canada? That'll be pretty cool. There are a lot of awesome game companies, right, in Canada. Okay, so what we want to do, that's pretty simple. All we're going to do is lerp from the first pixel, which is 0, and in our U coordinate, all the way to the bitmap width. Okay, this should give us the pixel we should be rendering. But this guy is in float. So the way we convert this to our actual pixel, because let's just see. Let's say we are right here. We're not in the green pixel, but we're not in the yellow one either. We're like here. The way we choose each pixel that we want to interpolate, that is our sampling function. For now, all I'm going to do is I'm going to add 0.5. It's going to make it round to the nearest one, and then I'm going to floor it with the int. Okay? I think I'm going to call it the bitmap width and height instead of x and y. I think that'll be easier. Study visa. Yes, that's awesome. I would love to speak English as good as him. Well, you'd love to speak English as well as me, not as good as me. I'm just kidding, dude. I got so much to improve on that as well. Okay, he speaks better than me, and I'm already completing 1 year outside Brazil. Yeah. Okay, I was just joking. One nice strategy to improve the English, just proves my point exactly. Pretty nice tip is to like listen to a lot of people talking like Americans or British, depending on the kind of accent you want, right? A little bit faster than usual. So if I watch like a stream, I usually put it like a little bit faster, so my brain kind of processes the language more naturally, and that really comes over time. So I have to Have to practice a lot as well. Okay, conversion from int to f32. Yeah. We're not going to lose any data. Trust me, this as well. Okay, conversion from int to f32. What? Which one? You're talking about this guy? This guy? The 0? f23. Okay. Conversion from float to int. Possible loss of data. Yeah, because these guys need to be in parentheses. My listening skills are pretty good. My real problem is when I need to speak right. That's what I did too. It really helped improve a lot my English, mainly the listening, watching online courses. Yeah, I don't know. My speaking kind of just came from listening a lot, I suppose. And if truth be told, the morning before my first stream, I was just walking on the park, and then I was repeating myself. I was talking to myself what I was going to start doing, like the very first introduction, and I explained like the context, things like that. And I talked like 4 times the whole thing, right? So okay, that's gonna be way better when I do it, right? But yeah, that was a one way to get more confidence, especially in the streaming thing, right? But I don't know. You should stream in English, dude. Even if it sucks in the beginning. Like I did some pretty you know messy things on my first couple of streams. There's one that I was like, I'm gonna do this, nah. And nah is a thing we say in Brazil that means okay. So just came out naturally. That was pretty funny. Okay, now let's check out these values. So the U and V are 0. And okay, so our lerp should be the very first pixel, which is the 0th pixel. Yeah. I don't know if 0th is actually a word. And our color, which is, yeah, a bit weird. So let's see. Next time around, we are still 0. Let's do like this a couple times. Nah, exactly. Nah. Okay, 0.15. Since we are 8 by 8 image, I think we're gonna have to go like way, yeah. This guy should be a different color. Pixel 2. So we moved to the other pixel. I think this is gonna work. I think this is gonna work. I don't need to do. Let me go back to the software. I don't need to do this every pixel. I can do it like this, and I can probably. Okay, that'll be good. Now let's see what we have. Hello, man. How are you today? Can I see the game? Sure. I'm great. How are you doing? Oh, dude, look at that. How about that, dude? So you brought pretty much good luck for us. We have a couple of problems, but those aren't big problems, I think. The first problem is our colors are wrong. Is it just me or this stream is lagging? Here it is okay. Yeah, it says that the bitrate is pretty good. It's like 2000. Okay, yeah, nice yellow color. Well, you're very observant. Very observant of you, Morpheus. So obviously we didn't get yellow. We got green, so green is correct. We pretty much just swapped our red and our green channels. Our red and our blue channels. Yeah, because Windows actually does BGRA colors. You know what I think I'm going to do? I think I'm going to, when I initialize our bitmap, let's do like, I'm going to like make a function out of this. Let's just do it like this for a while. I'm going to run through the whole bitmap. Bitmap height. Yeah. Okay, let's do y for x, and this is the width. Well, it didn't work. Okay, so we're going to run through the whole bitmap, And all I'm gonna do is I'm gonna set the, let's do like pixel equal to this guy, and we're going to do pixel is going to be, let's swap these channels, right? The pixel ended with this guy. This is the blue, right? So this guy you have to offset to switch the red by 16. It's probably gonna be wrong. And okay, so now we lost the red. Yeah, let's do it the slow way, just for us to understand. So R is going to be the pixel. Yeah, it's going to be this guy. But yeah, this is the R. Okay, and have the G and the B. Pixel. Which is your favorite language so far? I didn't know the game would have a colorblind mode. Yeah, I mean, we try to do as much as we can, you know, in our game. In fact, I don't need to do this guy. I don't need to shift. This is like the G, and this is the B. The B I'm gonna shift. I'm going to shift by 16. Okay, so this guy I'm going to build it like red. Oh, B shifted by nothing, right? Or with, let's do green. Also don't need to shift that because we didn't shift it in the first place. Or with R shifted by 16. Well, it's going to be right shifted. And I'm pretty sure it's going to be wrong. But let's see, X, yeah, we don't need X and Y anymore. Type in bitmap width. Thanks, guys. What? Bitmap, what the fuck's going on? Right shift to large amount of data. The blue one. Oh, the blue one is actually. Yeah, this is wrong. Like, this is what I meant, probably. Right? Yeah. Okay, so we're going to do like B, G, and R shifted by 16. Let's step through this guy, because this is kind of finicky, and we're probably getting it wrong. We could just do pixel 0 at this. Yeah, if I run like pixel through U8. But beverages are cooler. Yeah, dude, let's do the coolest thing. Static, non-standard static function declaration, function scope. Dude, did we forget this guy? Yeah, we did. Yeah. Oh, so the problem was I should cast to U8. That's why the right shift was getting all crazy on me. Now I should be able to right shift. No, I still don't. I don't know. Let's just see what happens when we try here. So R is 255, G is 0, and B, well, I'm not sure. I can't see B. You can't do U8 and then OR them all together. U32 was right. If you OR them, you can't do U8 and then OR them together. Okay, yeah, green is wrong. Yeah, I see what you mean. I see what you mean. This is also wrong. And this should be, yeah. I think I'm gonna do like the actual U8 for everybody. Yeah. Large shipper to amount. Okay. So yeah, thanks for catching that. Yes, so now we should be more correct, I think. Let's see, R 255, G 255, and B is 0. So this is correct. And now this should be correct as well. But now I have to shift all these guys. So I'm going to shift this guy by 8 and the red by 16. Maybe just get this wrong again. Do this, the other shift. Okay. Let's see. Huh? Just fix the colors. But I think I'm going to add, like Muji Go suggested, an if colorblind mode. Just kidding. Okay, nice. Yeah, that's pretty cool. Now, we are a bit weird, but I'm not sure this is how we're going to roll. I mean, we are actually weird in a couple points. The first point, let's just compare, right? The two images. The first point in which we are weird is that we are cutting half our first pixel, right? The other point is that, oh, okay, I think I see the problem. The other problem is this. And if you guys can see, we are not actually centered. See, so this is the image we're supposed to be drawing. So this is wrong. Let me go back. This guy is wrong. We're getting the pixel, but then we're offsetting by half a pixel. Yeah. Let's just see the other result, then we can play around with this. I would appreciate it. Ha! How about that, guys? Dude, that was so easy for bitmap support. And the thing is, that was pretty cool. Yeah, I mean, we have a very, very ugly bitmap, if truth be told. This is like pretty much the ugliest bitmap I could think of in terms of programmer art. But yeah. Now let's do some crazy stuff with this guy. We're going to do static x f32x equals 0. Then we're going to do x times equals dt times 5, I don't know. And then we're going to do the size, just so we can see how well we are working in terms of texture sampling. So we're going to change the size, and here's the x. Let's see some animation going on. Look at that, man. That's pretty awesome. I don't know if you guys can see. I don't know, due to the stream and stuff. And this guy, why is it not 1? Yeah, oh, it should be 10, really. Yeah. Since we're not subpixel accurate, when we move, we have that little weird thing in terms of subpixel accuracy stuff. And that's the next thing we're going to do. But before we do that, we are going to do some program art. And because after all, we are tightening up the graphics at level 3, right? Is that not what we are doing? I believe that is what we are doing. And just for the record, the animation on the block looks cool. Yeah, we added a lot of cool stuff on the blocks, man. Like, if you see like this one, which has the part-ups, we have not only particle systems, but we also have like, wow, that was a pretty, yeah, that's awesome. Frame rate was, yeah, we're going to do an optimization pass in a while. The player bar, yeah. That's what happens when we have a very low frame rate. It's pretty much, yeah, fixed player scale at low frame rates. We're gonna do that. Okay, now let's do some pixel art, shall we? This is gonna be pretty bad, I think. But it just has to be better than what we have now, which is not gonna be too hard, I suppose. So let's do like a yellow block. Oh, that looks nice. And let's do like a slightly darker border, maybe like this, like a crate. It's not a bug; it's a feature. I thought it was intended. How long have you been programming this game? This game, dude, not very much. If you go to the YouTube page, which is youtube.com/danzaydan, you can see the whole process in which we've been creating the game. Let's just quickly add up. We have 2.5 hours, then 4, so 6.5, 8, and 45. Then we have 11. Is that it? 11. Oh, let's say 12, 45. Then we have 16, 45. Oh, is that right? Yeah, that's right. So 16:45 plus 3, we have 19:45 plus 2.5, we have 21:15, 22:15, 24:45, so 25, 27, let's say 28, plus we have like 1 hour today. So let me exceed the math. So we've been programming this game for 29 hours. You can see the whole thing on stream. So this is like 3 days, I'd say 4 days worth of program. Oh, yeah, less than 4 days, 3.5 days worth of programming if you were to doing like this full time. And you can see the whole thing. And that's from scratch. So I think that's pretty impressive. So this game's been pretty, it's not too long. So let's just make this guy a little bit cooler. Maybe we can add like a, I don't know, bevel effect. I don't know, this is very low resolution, it's gonna be weird. Yeah, I think this is kind of okay, although it's pretty bad. So this is the invincibility one. So cool. Yeah, I think we're getting a pretty cool result. Okay, now this is weird. I'm trying to make like a shadow guy. Yeah, maybe just like this. Maybe it's gonna work for now. Or maybe we can do like more pixels. Yeah, let's do like this for now, and then we can do the other ones. So this is the invincibility. Let's just remove this guy and like remove this guy. So this is the invincibility one. We have the 3-shot one. So let's do a 3. Let's get the color again. The 3-shot one. Yeah, well, that's so bad. I don't know if I'm going to do, almost hitting the jam deadline. I don't think I'm going to do the pixel art on stream. I don't know. I'm kind of thinking about that. The 3-shot and the comment. Because I'm not really an artist, so not sure this is going to be interesting to see or not. So let's see like this. Okay, that was better. Maybe the T can do like the same thing. Maybe not do like a giant T. Let's do it. Maybe we can draw. That could be cool. So we're going to draw like this for a triple shot. I don't know. We're going to do it like this. So this is our this is our, let's say, comet power up. And then we have the triple shot power up. Then we can do better later, but one step at a time. Let's say data and the triple shot. Okay, now what we're going to do is we're going to load these bitmaps. Oh, first of all, let's make this guy function, right? So in this software rendering, we're going to do like an assets later on, but for now, let's just do in the software rendering, we're going to do like internal bitmap, correct? Yeah, load PNG. And that's what we want to do to load our PNG. Return. Oh, let's do like a bitmap. Oh, we can do like a bitmap result. Bitmap result. Okay. Yeah, we can free this guy later on, but I don't think we care. So bitmap pixels, just like result pixels. Let's see, bitmap result. Okay, return result. Yeah, okay. Okay, now let's do a lot of bitmaps. So we have the player stuff. Let's see where we have like the invincibility. This guy. Let's do it like this. Let's do the bitmap power up invincibility. Bitmap invincibility. Bitmap triple. And bitmap comet. And then in the initialize, we're going to load all these guys. Load PNG. And after, in the final pass, we are going to do pack file, things like that. But for now, I don't know. I don't actually know. For now, let's just do like the comet and the triple. So this is the bitmap invincibility, bitmap triple, and bitmap comet. Okay. Okay, now when we draw power-ups, I don't know, power block. Yeah, this is it. So instead of doing this, I'm going to do a switch on the power block kind. Case we are a power invincibility. We're going to draw bitmap invincibility, these guys here. Okay, and then we're going to do the triple shot. And then we're going to do the comment. Okay, and the default case, which are the power downs, we're going to do the red guys like this. And then we can make them later. Cannot convert. Yeah, it's going to be a convert to this guy. Are you return a local variable? Like this you're talking about? For the bitmap? I'm just straight up copying that on the stack because the bitmap is like the result, yeah. This guy is just a pointer and 2 integers. So yeah, I'm just pretty much returning the whole variable. I could like, since this guy is allocating, right? This guy's allocating for us the actual memory. This guy's also allocating and not free. Like we should probably like free. I don't know. But this is an 8x8 bitmap. Who cares? So I'm just straight up copying the whole bitmap to the stack, which is like 8 bytes. 16 bytes, pardon me, yeah. Okay, let's see if we have what we want. Okay, guys, you saw that? You saw that? That was the invincibility. This is the comment, and I like comments, so yeah. Another comment. Dude, we are really missing our frame rate when you got a lot of particles going on. Yeah. Okay, our invincibility didn't work. Yeah, see? We should probably limit, and this infinite loop we are running, this is the particles stuff. So let's see. We are now supposed to do like a lot of particles this frame. I don't know if you guys remember when we were doing the particles, we said, okay, let's get the distance the ball traveled this frame, and just spawn that number of particles. So if we do, yeah, so this gets incrementally worse, but it does look pretty nice. We are going to have to. And you know what? Like, let's see the tray. Yeah, this guy. I'm not sure, but maybe we should really do like one ball per frame, most. Yeah, I don't know. Yeah, not really. Since we do have alpha, yeah, I don't know. Let's see how this looks. But dude, having bitmaps is so cool. Our invincibility, okay, so we got it wrong. We got triple shot, and we are displaying the invincibility. Bitmap triple. Maybe I exported that wrong. Oh no, yeah, bitmap. I think it's just a typo. Bitmap invincibility. Yeah, this one should be triple. Then I have some work to do and gotta attend a meeting soon. When we stream again. Dude, we're gonna attend a meeting like Friday, 8 o'clock in the night? Come on, I'm just kidding. When will I stream again? Probably tomorrow. I'd say 4 o'clock. And then we're gonna do audio probably tomorrow at 4 o'clock. Yeah, and then Sunday, probably at 9 or 10 in the morning, we're gonna do again, and then we're gonna do, see Morpheus, Sunday 10 or Sunday 9 o'clock approximately a.m. Brazil time, which is BRT. We're gonna do multi-threading. That is gonna be cool. So yeah, now we should be limited to one particle per frame, which I think is actually what we want. Maybe we can play around with the alpha to be a little bit more intense based on how much we traveled. Yeah. But we shouldn't have like a million bazillion particles now. We should keep a particle counter just for fun. See, comment. Yeah, so see, that was pretty reasonable. And I don't think we dropped the frame rate. Now we should really have the invincibility. And we do. We should have the comment. Oh, and this is the triple shot. Oh, dude. But anyways, good stream. I'll be there next time. Thanks, man. It was awesome to see you here. Yeah. Dude, adding that bitmap made a lot of difference. And it's a pretty bad bitmap. That says a lot about art and game design. You know, how really, even though, you know, the game design has pretty much nothing to do with the art, the actual feeling the player has when he plays the game, which is what the game design tries to accomplish, right, has a lot to do with the art. So it's a little bit of a paradox there. Huh. Yeah. Awesome. Yeah, goodbye, man. Okay, so I think that was it. Let's do the power downs. Let's do the power downs. Let's add like a hue and saturation adjustment, and let's make them look evil. like, that's kind of evil, but that's not readable. So let me drop this guy to the bottom and this guy here. Yeah, but then I don't know, let's say we do like black, and we have the slow player, inverted control, strong blocks, and insta kill. Maybe we should do like B for blocks. Let's try to do a B here. 8 by 8. I think I'm gonna do 16 by 16. Yeah, let's do that. 16 by 16 pixels, and let's do this nearest neighbor resampling. Did that do anything? What happened? I don't know what I did, but now I can't change it to pixels anymore. Dude, that's weird. I'm just going to create a new one from scratch. Yeah, see? Dude, there's a lot more pixels now. So let's get these colors. Okay, now let's do it like this. Adobe. Yeah, I'm about not to use Photoshop anymore, I think. Let's see. Yeah, let's do like this detail. Like we're supposed to do like 3. Yeah. Okay, that was reasonable. And then let's do the giant eye. The eye of Sauron. Okay, yeah, that's the T. let's save that. Let's save that as the triple shot. Oh, I accidentally saved that on this guy. Let's just quickly do that again. Okay, now let's erase that. Okay, now let's do the invincibility one. Oh, way better, yeah. Okay, and then where's my glass? Where's my cup of water? Where's my glass of water? Did I not get one? I don't think I got one. Artistry now, absolutely. If you can call that art, I think you're pretty much a postmodern at this point, Marvius. And a comment. You know what? Let's do a C. Let's do an artist C. Let's do it like this. How about that? Isn't that an artist's C? Oh, got that wrong. Huh? Okay, that was. Let's see, maybe this guy. Where did I add this guy? Like this. This is not symmetrical for some reason. Yeah. This is not symmetrical. Let's try and do it like... That's weird. So, yeah. I think it has to be something like this. Okay. Oh, this is the problem. This guy. Yeah. Okay. Now we're looking good, are we not? How about that? That's cool. We can even do like this as transparent pixels. If you want to do like bitmap and transparency, that could be cool. So this is the comment. Now let's do our evil pickups. Okay, this looks pretty cool. Let's try to do like a dark gray, and let's try drawing a skull, just because now this is an artist stream. Oh, not that bad, is it? Good luck. Dude, how bad was this? It's not like really bad. I mean, it's not really, doesn't look like very deadly skull. This is missing a nose. Oh, dude, that was... Oh, but it's a nice reference. Yeah, but I don't think we're gonna do this kind of smoothing. We're gonna do like nice sharp pixels. So I'm gonna do these pixels. Let me just turn this opacity down a bit. Yeah, let's do these pixels. Dude, that was totally not what I was trying to do, but I'll certainly take that. Okay, we are not symmetrical. Now we are symmetrical. Let's add a nose. Let's add like a nose like this. Does that look deadly enough? Maybe we should like add a mouth like this. Maybe we should do like the bones. Or maybe, I think that's gonna be cooler than a skull. I'm gonna do it like a TNT. Yeah, let's do a TNT. T. N. T. That was actually surprisingly good. How about that? I liked that. So this is our insta-kill. Powered down. Insta-kill. Yep, that's nice. Yeah, I liked that. Okay, now let's do the other ones, which are the slow player. Let's do like... Let's try to get like a traffic, like slow traffic sign, just for fun. I'm gonna get some water, like because I've been talking for like an hour and a half, and I really need to drink something. 1 minute break. Okay, I'm back. So we were doing the, which one? We did the, yeah, we were gonna get like a slow traffic sign reference. Yeah, I think I'm gonna do that just for fun. Like, yeah, let's try to write slow in pixel art. Oh, that was too big. Okay. Maybe you're gonna do like a small L and a small O. Almost. We need more pixels. Let's try to do like a smaller S. This may look pretty bad. Can we do like a 2x2 S? I don't think we can. I don't think we can. Like, yeah, the W also is going to be kind of hard. Draw a turtle. Okay, let's try doing that. Like, let's do like a pixel art turtle. Yeah, let's do something like this. Or this one's pretty funny. Okay, let's do a turtle. Then let's do like, oh dude, that's so bad. I should make this guy a little bit bigger. And this guy like this. Okay, that's better. Okay, now let's do the feet and the tail. Okay, maybe. Where should I put the tail? Like here? Okay. Oh, that wasn't too bad. I don't think. Let's try, adding some darker spots and some lighter spots because we're doing lighting, guys. This is like some pro pixel art. Yeah. Then let's do some eyes. It'd be funny if we could, yeah. Yeah, let's make it like, let's turn off this pixel grid. How do we? It's missing its head. No, this is the head. This one looks pretty bad. Let's make it just a tiny bit darker. And let's do like a darker green. How about that? That's pretty cool, is it not? I like that. Okay, that's our slow. Power down. Now, we need a, what are the other ones? Pretty good. Yeah, if they turn out okay, actually. No kidding. I mean, if you look like from afar like this, We could add more detail. Maybe we can do like inverted controls. That's pretty cliche, right? We do like inverted arrows. Do like arrow like this. Wow, that's a really bad arrow. I should make the arrow head first, because that's the trickiest part. Okay. Yeah, okay, I'll take that. I'll take that. Let's flip that. I don't know. Which one looks better? This full, yeah, I think this one looks better. Full arrow. We also have to move this guy like, yeah. Not too fancy, but I think that'll work. Okay, this is the inverted. And I don't think we're gonna keep the insta-kill, just, I don't know. And now that we know what part down we're going to face, it's gonna be way easier. And strong blocks. I really want to draw like a muscle block, like I don't think we'll be able to do that. Oh, let's see. We have a block, and I want like some huge arms coming out of it. Like this. I think it's going to be too abstract. No, actually, this is not too abstract, is it? I don't think we'll be able to do it in both sides. Let's see. That was actually pretty good, to be honest. I'm surprised at this idea. Let's try to make this guy a little bit darker. Like this. It's kind of funny. But let's see if we can still do the strong blocks. In this amount of pixels, like this. Does it still look like a strong block? I think it does. But now we are 1 pixel off. Well, just make this guy a little taller, wider. Yeah, okay. I think this is gonna work. This guy. Yeah. Dude, how about that? I'm really proud of myself here. Let's get the hands a little bit darker, as well as like the muscles. Nice, nice, yeah! I mean, I don't think people will get this. Oh, let's try to get the block color to be the same. Let's try to do a blue guy, just so the players can relate a bit more. Yeah, maybe. Let's try to get the actual color. Did I not print the screen? What happened? Yeah, now I did. What's wrong? I can't print the screen. Okay. Let's try this guy. This blue. I don't think there's enough contrast. Let's try a little bit darker. Okay, that'll be the strong blocks. This one is actually not bad at all, I think. This is actually worthy of a pixel artist, like a programmer pixel artist. Now, this I'll call art. Okay, data and the strong blocks. Is that all? Yeah, we did 4. And we have 4. Okay. Now I have the bitmaps. Let's do more bitmaps. Let's do bitmap strong, bitmap TNT, bitmap. What were the other ones? Turtle. And bitmap inverted. Okay. And then we're going to load all of these guys as well. So we're going to load the, I don't know, let me just open here to make sure I'm calling them correctly. The insta-kill, which is the TNT. Loading the inverted. Oh, I call this inverted. This one is the slow. I should really keep them the same name, but who cares, you know. And this is the turtle. And this is strong. It's also called strong. Okay, and now in the default case, we're also going to draw. Yeah, we do like invalid default case. Okay, so comet. Let's do insta-kill. Then I'm going to draw the TNT. For the slow player, I'm going to draw the turtle, the inverted controls, and the strong blocks. Okay, dude, that making, okay, so, oh, I didn't actually see what was the assert. Probably got a name wrong. Inverted. Oh, it's all called power downs. Okay. Making games is a lot of fun because of this, you know. You have to do a lot of different stuff. It changes it. Yeah. Okay, so see? Inverted controls. Let's just test. Oh, crap. That wasn't a good idea. Invincibility. Yeah, we're invincible, who cares? Comet. Triple shot. Yeah, TNT. So this one we can't actually get. Ah! Okay, so I had to get. Yeah, okay. And it's gonna be cool when we add the interface to show how much time you have. Maybe we should do that today. I don't know. We're gonna do the yeah, strong blocks. They're not readable. It's not enough contrast, I think. Oh crap. The turtle looks pretty cool. Oh, I don't know if you guys got to see that. The game looks really good so far. Thanks. I also think that's getting. See the turtle? That's pretty cool. Let's get the turtle. Oh crap. Oh, not good. Oh, okay. And let's see the space invaders. This one has a ton of power-ups. Yeah, I think I'm gonna draw, instead of like the letters, I think I'm gonna draw the symbols. Let's just make this guy a little bit darker. Like this. It's gonna help readability. I don't want to make the blue darker, just the arms. Let me separate the body from the arms, and then I'll make it darker. Like this. Yeah. I think it's going to be better for the strong blocks. Maybe I should also increase the contrast of the turtle. I don't know. I think the turtle looks nice. Maybe I should remove this guy. I don't know. It's okay. Now, let's do more interesting things for the comet and the other guys. So the comet, I'm actually going to draw a comet. Let's try like a white border and like a red edge. And then let's do like this. And you know what? I think it'll be easier to print our comet. Okay, let's try that one more time. Okay, now I think that'll have to do. So this is our comet. So we have a white center and a red body like this. Yeah, maybe I'm gonna do it like this. Yeah, and then we get less opaque. So let's try the 80% brush. Yeah, let's try like this. And let's like a 40% brush. That was too much. Yeah. Okay, it's gonna look cool, I think. And then a 20% brush. Then a 10%. And then a 5%. Then like a 2%. Yeah, I think that's really cool. But I think that was I'm gonna do that again. Okay, so we have a white core. Oops, white core, and these guys are gonna be 100% solid. Okay, let's do like 90%. This guy, 80%. This guy, 70%. This guy, 60%. 50%. 40%. 30%. Yeah. Okay. You know, let's do 80%. Then we'll do like 60%, and 50, and 40, and 30, and 20, and 10. Okay. Yeah. How do you like that? Dude, this is almost real pixel art. Almost. But we're getting somewhere. Maybe I should take like a pixel art course on Udemy or something. Then I can make this pretty cool. And then we'll do like an art stream for reals. Okay, so this is the comet. Let's do the triple one. Yeah, the triple one. That should be easy. What are the colors that we picked for the triple one? If we manage to get one. Look at that comet. That's really awesome. Oh, I should really get the comet. Oh, I'm slow. I don't remember the colors we got. Dude, how many slow guys I got? I'm still slow. I don't know. Let's cheat and look at the ball. Let's see. Yeah, draw rect. So we draw the ball white. Oh yeah, the difference is the trail. So if we do. So we are blue and yellow. Yeah, we can't do yellow. Maybe I'll just do blue for all of them. Yeah, let's see. I don't know how well this is gonna look. Let's see, 40%. Gonna do like 60%. Gonna do like 30%. And then do like 20%. It's gonna be pretty cool, I think. Yeah. And then 10%. Okay, I kind of like that. I'm gonna move him like 1 square up like this. And then increase like everyone a little bit, like increase this guy, increase this guy, increase these guys. Yeah. Then I'm just going to demo a literature game and I wanna program one myself right now. Dude, that's the spirit, man. You should program one yourself. It's really, really cool. Yeah, I started this stream because I was inspired by watching people make games, dude. I want to make. Okay, so that was a failed copy. No, it wasn't a failed copy. What happened? Okay, that was just Photoshop being messed up. Yeah, you should program one yourself. It's really, really cool to make games. I think I'm gonna increase the contrast on this blue guy just a little bit. And maybe like this. Not the contrast, like the alpha. I think it's looking good. Dude, I'm reading the pixel art field right now. This is gonna be like an art stream. Okay, triple shot. Invincibility. Do you guys have any ideas for the invincibility guy? I don't know. Let's play it for a bit. I don't know. Yeah, bitmaps make a lot of difference. Yeah, the eye is pretty boring. Maybe I should draw like a force field beneath the player. Look at all those guys. Okay, I got strong blocks. Yeah. Okay. That was a pretty cool strong blocks behavior. Oh my god, I have to totally leave Oh, managed not to get all these turtles. The game is fun, honest. Oh, missed it. Okay. Yeah, let's see. We have inverted controls there. Oh crap. Oh, okay. Total. Yeah, that was your idea. You can't complain now. Let's free this guy. We just do like free. Well, let's do free file. We're only using this for files. And then we free the image. Okay. Yeah, I don't know what to do. I think I'm gonna draw a force field. Maybe like a green force field. What is that? Dude, I missed a semicolon. Look at the error they gave me. Come on. Yeah, let's see. I think I'm gonna make a green force field because the player is green. So let's see what we have. I don't know. We could also make like double points for power-ups. Okay, it's not too bad. First time around, players will not get it. But maybe you should make like a white player. Yeah. Yeah, like that. Yeah, they'll totally not get it the first time. But I think that's okay. And we're going to get to test now our guy because we're gonna make like a 1 by 10 texture and we'll see how well we managed to create our texture guy. So let's do a 1 by 10. Let's do 1 by 20. Let's do like a somewhat smooth gradient. So this is 100%. Oh, actually, okay, now I'm gonna do like alpha. Yeah, alpha bitmaps. So 100%, 90, 80, 70, 60. Oh, actually, I'm gonna get some sleep. Thanks for the stream. It was nice as always. See you Sunday for the threading stuff. Bye, Morpheus. It was awesome that you could join me today, and I'll expect you Sunday when you do some awesome threading. It's gonna be really, really cool. Bye bye. So 95. Then I'm gonna do 90. I'll be there. Bye. See ya. 85. This is kind of the weird slash boring part of making art, even program art, because I want to do like quality program art. I don't want to do crappy program art. 60. Maybe I should really do like by 10, because I do want to see the pixels. 50, 50, 55, 50, 45, 40, 30, 35, 30, 25, 20. Oh, did I miscalculate it? 15. No, I don't. I did 10 and 5. Okay, that was perfect. 5, not 50. Okay. Now we don't have alpha support yet. And in fact, let's actually make the alpha channel, right? Okay, I think it's gonna look pretty cool. Then let's do like everything plus the alpha. Let's export with transparency. Okay, I'm not sure this is gonna work. I mean, even when we implement alpha, but I'll do it just for fun. Then I'm gonna do subpixel sampling. Okay. Now, breakout data. Let's do like force field. And let me see the bitmaps. Let's also do like bitmap force field. Yeah, force field. And then if we are invincible, we draw this guy, and then we are supposed to draw the force field as well. So draw bitmap. And I'm going to draw the bitmap force field. The position is going to be, let's say it is 0, and then the player visual py, and the size is gonna be the arena left, right, plus the arena right, and let's do like 10 units. Yeah, again a pointer. Maybe I should take the whole bitmap. DDP. Yeah, no, not DDP. Thank God it wasn't DP. That would be a weird bug. And in fact, let's make us invincible. Okay. With 0. I couldn't load. Oh well, I didn't load the bitmap. Load PNG. Bitmap force field is going to be the force field. Dude, I should have done this earlier. This is really cool. It's really fun. Okay. So let's implement the alpha. The alpha blending. Yeah, let's do for all of them. Alpha. Yeah, and we're lerping. Yeah, this lerp's not like the best thing ever yet. But yeah. So alpha will be clamp f of 0, alpha, and 1. And then I'm gonna take the alpha. Well, this is wrong. This is wrong. The alpha will be the color. Alpha, which is like 0, 0, 0, F. Is that it? Or is it the... Yeah, I think that's it. Divided by 255. I'm not entirely sure. I am going to have to step through this guy first. So our color, let's see that in hex, is 0, green 0. Okay. It's gonna take a while. Yeah. Well, let's just see. It's gonna be easier. Yeah, and we see nothing. If well, let's see the power-ups. Well, it's gonna be hard to tell if you can't see them, right? Okay, this is interesting. I'm gonna put like a breakpoint here if alpha is greater than 0. Oh, dude, this is gonna be so slow. I don't think we'll be able to play that. Since our random number starts with the same seed now, I kind of know already which ones. Yeah, I kind of missed the power-ups. Okay. You know what? Let's remove the force field, the force field draw call, and then let's put a breakpoint here. Oh, actually, I thought maybe it's the second one. I thought the first one had a power-up. What? Maybe we're just invisible. Okay, no, we're not invisible. So the color, let's see, is 0, 0. This guy. Maybe the alpha is 0. Yeah, I think the alpha is 0. So the alpha should be 0, but it's half. Yeah, maybe I'm getting the wrong guy. This is supposed to be the alpha. Well, it's not, right? I mean, when we change the B... Oh, because we put 0. Okay. Yeah. Now I have to also get the alpha. A. And the A, the alpha is all the way this guy. No, this is wrong. This is the alpha. Yeah, 24. Then we can OR that with the alpha moved. So the first guy is the alpha, like this guy. Okay, and I'm going to have to shift that by 24. And then we divide that, and then, okay. Let's see. I suppose the seed is kind of random. I don't know. This is like super wrong. Like even if we were not supposed to have the actual alpha, we should be like all transparent. But we have like one line. Yeah, let's debug that again. Okay, the color is FF. Yeah, this is what we expected. And the color. So if we end this guy with this guy, yeah, this is what we have. Actually, we don't need to end, we should just move. And then we move 24. Looks about right. Oh, we didn't cast to U8. Oh, but I don't think it matters. Alright, so this guy, F32, divided by 255. 1. Okay. So we should get 100% of the color. Oh, we're not incrementing the pixel. Because we copied this guy from the alpha, but for some reason the alpha guy is not incrementing the pixel. Yeah, because we have this condition and we don't have this condition because we're not rotating. Okay, that was a weird loophole. No. Okay, now we're back to working. And we can do some nicer stuff with this guy now that we have transparent bitmaps. Now, let's go back to drawing, no, not this guy, to draw a force field. Oh, look at that! If that's not super, super cool, I don't know what is. I'm going to draw that before the player. Remove that. Oh yes. Now I'm starting to get. I think I'm gonna do the random seed today. Shouldn't be super hard, and we're actually going to see. Oh man. Oh, but we are pretty slow. Oh, don't like that. Yeah. I mean, we're not super slow, but we're not super fast either. Dude, this is starting to get really cool. Software rendering is awesome. Yeah, but this is like the unoptimized build. It may actually be okay. Yeah, I'm probably also going to have to lerp that to make it not as strong. Let's do that. So we did bitmaps. Let's do like power up bitmap use cooler alpha. We're gonna do force field in and out animation. And there was one more thing. I don't remember now. We're going to do the subpixel rendering. I am not sure. Well, I don't know. But I think I'm going to do for these guys is actually like get the eraser to 50%. I'm going to kind of erase these guys. And these guys. I think it's going to be really, really cool. I'm going to have to export all that again. Okay, so this is the comet. You know what? I think I'm going to save this guy. I want to save that anyways. I'm gonna create like a raw and like power ups, just so it's easier to go to the directory when I export the PNG. Oh, and let me just see if just checking this transparency it works, or if I have to do like the channel thing. It may just work. Let's see the comment. Oh, and the random seed. Ha. Random initial seed. Okay. I think one of these guys here in the bottom left, in the right, are comments. The force field. It's going to be a really subtle animation, but I think it's going to be cool. And I don't know, maybe we shouldn't do the force field like this. Maybe we should do like a lighter on the CPU version of this. Don't need to do it like a bitmap, because it covers a lot of the screen. No, it kind of worked, but it was kind of ugly. Don't know if I liked that. Let's see the Space Invaders. Yeah, I didn't like that. Yeah, maybe just the border ones. No, actually I did like that. That was pretty cool. I didn't like these guys. So I think these guys, let me see. These guys I'm going to go back to 100%. Like this. And the center ones I can keep like this. Okay, I think that would be a cool solution. And it did work. Just by doing the setting the transparency when we were exporting. Dude, this is like pretty cool, I think. Yeah, I am liking it. Okay, triple shot, force field. So now it can be called force field instead of like invincibility, because now it's a real force field. Okay, now we turn this guy on and then export the strong blocks. Maybe we should do like a little bit thicker strong block. I'm thinking like, yeah, I think it's gonna be way more readable. Kind of liked that. Then we do, let's see, strong. Oh, okay, forgot. This is supposed to be the strong. This guy. Yeah, we have to do some optimizations in the rendering now that we are doing some crazier stuff. Because I think I want to ship this render. I don't want to ship a OpenGL render this game. Time will come when I'll do OpenGL games, but this first that I'm doing like showing you guys the process. Yeah, I think I want to do software. The turtle. We can probably improve that later on as well. Turtle. That's a hard word to say. Turtle. Okay. Let's keep going. TNT. And we are done. Okay. Now, probably do the in and out animation. Oh, let's also do a optimized build. I mean, we're not going to do any crazier things in the terms of yeah. Oh, this is pretty cool. Not going to do any more crazy things in terms of oh, and almost got it. Okay, I think this is perfect. Let's do the player. Well, we have the invincibility T. Let's do like invincibility alpha. Think about what's the best way to do this. Yeah, I think I'm going to do that. And then I'm going to draw a bitmap. Okay, now if invincibility alpha is greater than 0, I'm going to draw. And if it is greater than 0, I'm going to subtract, let's say, the dt times 2 until it is not greater than 0. Oh, no, that's not correct. If we are invincible and it's greater than 0, we should do nothing. If it's not greater than 0, let's say if it's less than 1, we're going to increase that. So dt times 2. I don't know, let's do 10. 5. Okay, now else if it's less than 0, if it's less than 0, we should also, yeah. I suppose that's the only thing we gotta do. If it's, yeah. But in this case, if it's not 1, we should probably render that for a couple of frames. So if the alpha is, if it's greater than 0, we're going to decrease that and draw the force field. Okay, now this is kind of convoluted, I think. But I don't know. Let's see. Let's make all the wall blocks give give the power invincibility, just so it's easier to test. Okay, that certainly didn't work. So we expected not to be greater than 0. Yeah, that was a problem. Oh, the invincibility T, yeah. We expected it to be less than 1, so we would grow. Okay, yeah, it is correct, but we're not actually using it. So we're going to pass like the alpha here. Then let's do an alpha multiplier. Then we're going to do the alpha multiplier. I'm going to clamp at that. Okay. And here, I'm going to multiply everything by the alpha multiplier. Okay, now these guys should all be, let's do like 1. Too many parameters. Okay, yeah, this guy is too many parameters. Invincibility alpha. Did I have an alpha? No, alpha undeclared. Draw bitmap. Yeah, this may actually be smaller than 0 in a couple of cases, or greater than 1, but I don't really care. Yeah, okay. Now let's see how that looks. Perfect. Okay. But why didn't we see the player? I think we deleted. Yeah, we did delete the player guy. That was weird. Yeah, I don't know why I did that. Okay. Let's see if our invincibility is nice. Perfect. We could probably lurk the player's color, but it's gonna be hard. Okay, but we're not finishing. Yeah, if it's less than or equal to 0. Yeah, I shouldn't have to test this. If the invincibility alpha is greater than 0, subtract that, and then draw the first bit. I think the speed was pretty cool. I liked that. Well, actually, I couldn't actually pay much attention because I was trying not. Yep, yeah, I think I liked that. Let's just remove the everyone giving invincibility. Yeah, like this. Okay, force field in and out animation done. Let's do random seed. Today we are on a streak. Okay, they look pretty cool. Yeah, perfect. Oh crap, I got inverted control once. Oh, the TNT. And back to normal controls. Okay. Okay, this is pretty tense. This is really cool. Yeah, let's do the random seed. The thing is, we need something that is unique for every playthrough. I mean, kind of unique. Doesn't need to be the most unique thing ever. Kind of this game, right? Kind of joking. Okay. Oh, nice. And what we're gonna do. Nice again. Oh crap. Oh, okay. And what I think I'm gonna do. Let's go to math. Someone has to provide a seed, right? Random. Yeah. Let's make the Windows platform layer where we get like this first last counter. Let's set the random state to that, and let's print it to see if it's unique. Last count, I think the large integer has a large integer SDN. I think it has like the oh, it only has the quad part. I think I thought it had like the low bits. Yeah, well, I suppose I can just cast that to an int. Okay. Dot quad part. And let's print the random state. Print int. And I just make sure before we do that, let's see if we got 1, 2, 3, and we do. Now let's see what we have. Okay, 5, 4, 4, 4, a lot of stuff. 5, 5, 8, 1, 5, 6, 5, 7. That's perfect. And then just by doing this, even if it's like a small difference, we're going to have like substantially different random numbers. So see, before, this first one pretty much always had the random guys, and it still does. Well, let's see if in this run it does. It doesn't. Perfect. Nice. Oh, okay, so there's this bug. Let's try to fix that as well. Today is a crazy day, good day. Let's see, I think let's see, block life. Yeah, I remember typing it, but I don't think we got that. So, the invincibility only tests out when we are killed. And what we really should test, like, let's say the ball, update ball, yeah. Like, balls. See, we test if you're less than 50, if we lose a life. Okay, and if we don't, we should really, we should hard code the desired, this guy to -50. I don't know if you guys saw what happened. The idea was that the ball was pretty much already down when I got the life, so it kept going forever. Kind of like that. Okay, minus the ball half size, but that's not supposed to change much. If the ball desired P minus the half size is 50, it's -50. If we are invincible, we lose a life. If we are not, invincible, if we are invincible, we set that in reverse. Yeah, let me test that. I think this may actually work. Surely play around with this. Okay, I'll have to do it as well. Okay, that was a failed attempt. Yeah, and we do have a couple of twitches in our. Okay, perfect. Now we do have to test those harder cases, which is like when the ball is pretty much already past me. But I think this is gonna work. But it's harder to test. Nice. really nice. Oh, okay. It's nice when you like combo a couple of a lot of yeah, having animations like that on the force field, it's really subtle, but it makes a ton of difference in terms of like that's the difference between an amateur game and a better game, I think. Well, that's one of the differences, but that's a pretty major one. Oh, that was a wasted 3-shot. Okay, now fix that, fix the other thing that we didn't write down. Real brick, reward player with power-ups. Maybe reconsider, okay, so we didn't write down. Subpixel accurate rendering. Now let's do that. In order to do subpixel accurate rendering, I'm going to do a hack. First of all, let's really see the problem. So I'm going to draw a rect. Let's do like x0, then we'll do like, I don't know, 2, 2, and we'll do like this guy, and then we have a static x equals 0, x plus equals dt. When we have a slow moving object, I guess I have to see this pretty slow. Well, let's make it move a little bit slowly. If you have a slow moving object, yeah, see how its shape kind of gets deformed? Like it crawls weirdly. It doesn't move slowly. It moves like, sometimes they move 1 frame and other times it doesn't move at all. Hopefully you guys can see that. The problem is, let's go to our draw rectangle code. Problem is, yeah, here. We just clamp these guys, and even if you like did other float to int operations, it doesn't matter. The point is, this conversion to int, we're probably going to lose half pixels. So let's say this is the pixels that we're trying to go, and we're like here. Perfect, this should be 100% white. Now next frame, we're here. So it draws that as 100% white, but in this frame that we are here, it draws that at 100% white, and it doesn't draw anything like this. So it stays 2 frames on this guy when it actually should be moving, in quotes, and then it moves 100% to this guy. What we want to do is it's if 100% white, if it's in the center here, at this point, let's say it's like 80% white, or 20% white, and at this point, this is 0% white. So I'm going to hack this. I'm going to create a different call for the draw rect. I'm going to do like a draw rect subpixel, just because this will probably do more operations, probably. And I think we only care for like fast moving objects like the player, the ball, probably the power-ups, but the power-ups, since they are bitmaps, we have to do something. Yeah, but I don't know. They move fast enough that we don't see. But the ball, especially in the beginning, that it goes slow. Oh, I don't know. Maybe we don't need that at all. Let's just try to do it for fun, and we'll see if it makes it better. So this guy should be draw rect subpixel. Okay. Yeah. So nothing changes. Now the idea is we have this x, Let's just do it for like one axis for now, and then we maybe do like the two of them for the ball if it looks good on the player. So this is like the first pixel. Let's call that x0f. So this guy minus the x0, it returns a fractional value that shows how much we didn't manage to get across. Like, let me explain when I put a breakpoint here. So, well, oh yeah, we are optimized. Now I have to remove that optimization flag. Okay, now, and then I have to stop the execution. Okay, so we are supposed to go to the pixel, in quotes, 618.41. But we can't go to the 0.41 pixel, right? We can't. So this guy says, okay, start at the, let me close this guy. Yeah. Okay, this one says, okay, so start at the 618. And then we're going to ignore 0.41 pixels. So we should really draw, before we draw this guy, we should draw one before it that is actually a full row, a full column of pixels with this alpha. Sounds good? This sounds pretty easy, I think. So we're going to draw rect, well, pixels transparent. I think we need that again. So, yeah, let's do the lerp. This thing. Yeah. Okay. Same thing as before. And then we're going to clamp f alpha 1. Okay. Now, this is like what we did like 100,000 times, right? Now, now we're going to pass the x0f. But what are we going to draw? We're going to draw just the leftmost column, like this. But we're going to draw all the way from the y0 to the x0. So that's what we want to do. Hopefully, it should already work. And if you, well, we are doing something, but I think this is wrong. I think this is wrong. But I don't know if you guys could see. Maybe I should just amplify that. But we did have something. Let's see. Okay. It's kind of hard to see because this also happens on this side, although I'm not entirely sure why. But see that this is smoother. So the idea is the pixels are going to roll slowly. So the thing is, instead of doing like straight up conversion to int like this, I'm going to add 0.5, which is to offset that to the center of the pixel. That's what we expect. I don't know, it doesn't look correct. Let's just do this other guy, and let's pass like green. Oh, that wasn't green. That was red. Okay, so this is what we expected. just try to make this guy bigger. It'll be easier for everybody to see, but it's still just 1 pixel. So it won't be that much easier. You guys can see the green line, right? Yeah, this is correct. Now, we should really do the transparent calculations, passing the alpha. Oh, you know what? I think you can just print this alpha. It's going to be once per frame, and the alpha is going to move slowly. So we expect it to start like some random number between 0 and 1, go all the way to 0, then start in 1 again. That's what we expect, right? But since this is we should really do print float. If we manage to do this pretty quickly, which today we're on like a nice streak, we're going to do print float. Okay, print int undefined. Yeah, just going to for declare like internal void print int takes a random int alpha. This is actually x0f, which is a very, very bad name. From float to int, possible loss, we have to first multiply and then we do alpha. Okay, x0f. Okay, let's see the number. Okay, so yeah, this is not what we totally expected. It goes from negative 0.5 to like 0, I think. No, maybe to positive 50. Yeah. Let's check this. And then we can like debug after that. So let's say we want to draw, well, let's debug. Okay, so this guy, oh, we're talking about this guy. Okay, so we want to draw this pixel, but we can't. So we're going to draw starting from, yeah, 496, but we want to draw 445 at, so this was the problem. Oh, we should really add this guy. Okay. So let's call that x0f for reals. And this will be x0 alpha. Yeah, I forgot to add the 45, so there was a discrepancy there. 0x alpha. Okay, now let's see if you can see anything different. Oh, the value is huge. Well, this looks correct, I think. Well, but it looked correct before, right? And it wasn't correct. Now this guy, we want to draw this pixel. So we can't do that, so we're going to draw at the 4607. Okay, so we want, this is the 46. So we are like 0.33 in. And this tells us to draw that pixel. So we should probably add 1 to that. And this one It's going to give us like this guy. Let's just see some values. So we have this guy, and this guy. No, I think they look perfect now. Yeah. So instead of starting off in this guy, we start off at him plus 1. This guy is going to go all the way from him to him plus 1. Okay, I think it's going to be better. Let's see. Well, the alpha looks really wrong for some reason. And oh yeah, I printed the wrong thing. Should print the x0 times 100 and okay, let's see. Okay, this is better. I think. Let's do it like color. See if it's kind of slow. I'm gonna try to ignore. Well, that's not. That's not exactly. Should be maybe this should be like -1 minus this guy. It's going to invert because it was supposed to. Yeah, I know it doesn't look right. Let's try to debug that one more time. Okay. This guy says, well, I want to draw this guy at this position. Actually, at this position. But I can't. Right? This is the first 6. Then what I'm saying here is, okay, draw the row, his row, right, with 0.33 of alpha. Okay, so yeah, this looks about right. And then we're going to do this guy plus 1 all the way to the end. I don't know. Kind of looks right. Let's try to make him super slow. Like, and you know what? I'm gonna save myself stepping really close to the monitor and just adding this magnifier guy. I think that was just a bit too much. Oh my god, now it's like, okay. And it's also hard for me to see if you guys can see. Okay, let's try it like that. Okay, let's magnify. Oh, the mouse is stuck. Let's try it like this. It's like I don't even see any alpha change. Well, I see it getting stronger, the alpha. Yeah, it does. It goes all the way to 1. which is like the opposite of what we want. So I think that's the only problem. So this guy should have been correct. Like, it's like 1 minus this guy. Yeah, well, I actually said negate that result, which was wrong. So let's do like 300. Dude, that was perfect. Perfect. Really, really, really perfect. Let's make it move a little bit faster. How about that? Look at the difference. I don't know if you guys can see. Let me see in the stream. Yeah, it's hard for me to see if you guys can see because I'm so zoomed in. Let me try. Okay, I think you guys can see now. Look at the difference between the left part, which goes smoothly, and the right part, which does not. That's awesome. Let's add that to the right part, and then let's add that to the player. That animation on the top is pretty cool. Okay, I think you guys were able to see that. I'm not sure. Yeah, you were. Okay, let's add that to the other side. It's going to be pretty much the same thing, right? Let's do it like this. Calculate this guy. But now it's alpha 1, which is this guy plus. Okay, and then we do this guy, which is this guy, and we do this guy, which is this guy. That's pretty explanatory, isn't it? Great explanation, all these guys. And then let me step through this guy once. See the results. Couldn't I step through these guys? Okay, sometimes it doesn't come. I don't know why. Okay, so we want to go past the 768 guy. So I suppose the last one should be 768. It is. And so this one is going to be, yeah. So the alpha. Yes, I think this one, we don't need to invert that, I think. And okay, so this one's going to start out at this guy, and to this guy plus 1. Yeah. And I don't think we need to change any of that. Let's see. Dude, if that's not perfect, I don't know what's perfect. Let me try to zoom in again for you guys. And also so I don't like stick my face into the monitor. Yeah, but when you do stick in, when you go this close, you can see like the pixels changing. So maybe the best solution is not to go that close. And you guys can see, right? This rectangle, this square is moving like extremely smoothly across the screen. That is the benefit of subpixel accuracy, and I'm pretty happy with what we got. And I mean, it is a hack. I'm not going to say it's not a hack. It is a hack, but it was a pretty easy hack to do, I think. Now, the only thing we should do to add that to the player, I think, if I am not mistaken, I'm going to comment that because maybe we're going to do like the vertical one for the ball. Because the player only moves horizontally, so the only thing I should have to do is like this guy. And I think that's it for our rect. Yeah. Let's see the difference. Okay, well, it's kind of hard to tell. Yeah, especially with the spring. I'll make the spring, say here, make the spring less tough. Let's make like, yeah, like that. Just for us to test. Especially at the end, it moves a bit weird. Well, but it's not, I don't know, it wasn't that evident to begin with. So maybe it wasn't worth, well, it was worth to learn, but it wasn't worth like visually. I don't know, it does look a bit better, I think. Yeah, well, I think it's a bit better. But I don't think we're going to add that to the ball. Especially when you go fast. The ball doesn't move slowly like at all. Even like this, it's pretty fast. The player can move slowly. Well, but the Y, I got these guys wrong? Because see, the last row is getting messed up when I move slowly. Yes, now I'm extremely confused. I thought I was only changing, well, I think I was pretty wrong. Yes, I was wrong. These guys are wrong. I should only change the first row, so it's going to be y0 and y0 plus 1 and y1 and y1 plus 1. But I should go all the way from x0. No, it's the other way around. I want just these guys, so they go from y0 to y1, that's correct. But the x should really, well, that's correct. That's what I was doing. It's like 1 pixel, the width, and the height, the whole height. Oh, maybe because I do change the side. Yeah, I'm gonna have to do that for the player, the both. Yeah, because I do change the player size in X and Y, so it does flicker. So I'm gonna do the same thing for the Y guy. Okay, and let me just see what printf through 2. Yeah, I don't know. Okay, so see, we see the same problem, and I'm going to do the same thing. Like, okay, so this is P y0. Same thing for the Y. Okay, and then we do the same thing for the X. For the Y1. If you guys have any questions, just drop them in the chat and I'll try to answer them. Like about anything really that we're doing. Okay. Now same thing here, but we're gonna go from x0 to x1. So we go the whole x. Then we go from y0 to y0 plus 1. Then we go from y1 to y1 plus 1. And possibly we do this as well. Let's see. Yeah, well, I have to do like y. It looks inverted. like this should work. No, it's wrong. Okay, let's do it calmly. So the y0f, okay, and the alpha, okay, plus this guy. Okay, the values look correct now. This guy. We're gonna go from x1, so the whole row, and well, the four corners probably gonna be problematic, but I'm not sure what to do with them anyways. So, I don't know. This looked correct. The top one looks inverted. That's just wrong. Let me step through the code again. Okay, again, well, haven't done this guy. Okay, so let's see the top one. We want to go like all the way to pixel 82. Oh, because we are we top down? No, we are bottom up. Yeah, all the way to pixel 82. But I'm only going to drop to pixel 82. Then I have 0.22 to do to the other guys, right? So this is the y1. So the y1, I'm gonna go from the y1 to the y1 plus 2 and draw him with this alpha. That looks perfect, I think. Oh, yeah, now it is correct. And the y0, I start out at 45, 44. So I'm gonna do that and then do, this must be a stupid mistake because I don't see the problem. Yeah. I don't know. Let me try to look up close. That helped the first time. So let's see. Well, I don't even see. I don't even see the proper. Let's try to run that again. I don't even see the proper alpha blending, like at all. I don't see it at all. Let me just draw these guys, these two lines of pixels. Yeah, well, they are a point, they're not a line. But why are they a point? I'm going from x1 all the way, x0 all the way to x1. Well, maybe should be x plus 1, but doesn't matter. Well, let's see. I'm going from this guy to this guy, so certainly not a line. And we go like 1 pixel high. So this guy, I should go like and in fact I only see 1 point, not even 2 points. It's weird. Okay. Oh, the same stupid mistake last time. The same mistake. Well, last time wasn't like an actual mistake. But if that's the case, how? Well, yeah, it worked. It worked for the other case because we only had 1 pixel in X. So we would like do 1 pixel and then go back. But in this case, we should really add. Well, the other time I managed to catch this bug before it was problematic. In this case, I didn't. So I was intrigued for a while. Perfect. Perfect subpixel moving. Now let's add these guys back. We should also have perfect pixel move. Well, it's just for fun. Let's make it move diagonally. Okay, that's perfect. And I think I am not going to go all the way to this guy and this guy, just so we don't like draw twice on the same pixel. The left side looks kind of okay, but the right side doesn't, because this is really a hack for pixel perfection, subpixel rendering. So I mean, don't expect it to be like the best subpixel render in the world. Yeah, I still don't like the border ones. They're like, there's like 1 pixel. Well, the only one I don't like is the Y down. Oh, just this guy. Okay. Now we are way better, I think. We are way better, I think. Oh, I really like that. So, in the spring, I'm going to go back, maybe not to full, it was like 40, right? Let's do 30. Okay. Yeah, nice jelly player. Okay, now let's play around with the power-ups. Okay, yeah. Oh, I forgot that. I can cheat and add myself some life. Dude, that's awesome. The force field. Yeah, well, let's do the strong blocks just for fun. The TNT looks awesome and frightening. Okay. When we add the timers, it's gonna be really cool. It's gonna be like a perfect, like the visual timers in the interface. It's gonna be really nice to see how much like invincibility time we have, things like that. Maybe we can add, oh, now that I'm thinking about it, maybe we could add that on this guy. Like have him slowly fade out as we lose. Let's try that. That should be easy, and that probably would be better. Let's go back to the optimized build. Yeah, so we did subpixel aggregate rendering, at least for the player, which was the main thing that we wanted. So, you know what? I think the compile times are taking like a bit too long now, probably because of the library that we used. So I'm going to like do PNG only. Has to be only PNG. Yeah. So hopefully this will be quicker. Well, not really. STDI. No. Let's do no STDIO as well. Let's see. Decode memory or through file. No failure string. Yeah, we don't need failure strings. No like STBI, no. Okay, let's see what else we got. No SIMD. No, please, let's use SIMD. Yeah, that was it, pretty much. Well, it didn't change much, still pretty slow. Let's just like STBI. Let's just see if we compile a lot faster without this guy. Yeah, we do, but I don't know. I don't think we're gonna use that in the final game. But we're still pretty fast, so I'm not gonna complain too much. Okay, so now we are back to the fast build, and we're going to do the last thing for today, right? Which is the print float guy. I'm going to do a very hacky way. Let's go to the console and print F32. What was that? 32 number. And the way I'm going to do this is, first of all, I'm going to print int the number truncated. Okay. Then I'm going to print. Okay, I have to. You know what's the message? I'm going to do a message type. Like message int. I mean, if we had like fonts rendering, everything would just be a message. Everything would just be the message characters. But since we don't have font, well, we could add now that we have bitmaps. I don't know. I'm not gonna think about that now. Let's do like int val 32 val. Okay. So we do F32. This is what we do. And we do like F32 val equals number int val, and then message kind equals message int. .32 val, this is int val. Okay, but this, now we have to switch on the message kind, case message int. We do that. Case message F32. And invalid default case. Now, what we're going to do, we're going to have like a hole, which is the message 32 val, cast to int. Then I have like frac, which is the absolute of the message F32 val minus the whole. Do I need the absolute? If it's like negative 1.5, it's gonna be minus 1. So it's gonna be minus 1.5 minus 1. So yeah, like this. And I'm going to do like 2 digits, so I'm going to do like 100 times this guy. And then I'm going to do like this. So it's not going to be the most perfect F32, but it'll do for now. Then we're going to draw a number. First of all, we're going to draw the frac part. And in fact, let's test this guy. So f equals 0. It's pretty cool that down here is where we test our stuff, our test-driven development, right? Okay, we should do it actually before drawing messages. Oh, it doesn't even matter. Okay, then we're going to do print f32 f. We're going to do f plus equals dt. Okay, wasn't expecting that. Well, instead of doing that, let's do what we think we know how to do, which is like the whole part. Let's see. 0, 1, 2. Okay, this is correct. And see, it takes like 1 second, right? 1, 2, yeah. So what I expect to see is a number that goes from 0 to 99. Okay, yeah, well, stupid mistake. Perfect. Really, really perfect. And you know what? Our draw number in our renderer, instead of doing like this first digit thing, I'm gonna do like number of leading zeros. And if we pass 0, like the first digit would be like we can pass like 0 and then the default would be 1. So if number or number of leading zeros, number of leading zeros minus minus. So this shouldn't change anything that we did so far. But then this guy should do like 0, and this guy should do like 2. So we expect 0 to be 0, 0. I think. Yeah, see, that's where default arguments come in handy, I think. I think I may have one too much. Yeah, I do. But it is working. Although our draw number is not... Oh, what happened? Though our draw number is not probably do that. Make it... I don't know. I'm thinking about making it like monospaced, but I don't know. Draw number. Okay. For some reason, the number of leading zeros is very small. Like, really, really small. That's weird. Let me just set next statement. Okay, so if you are 3, go to 2. And then go to 1. I don't know why that happened. I should say like while leading zeros is this guy. But not sure why that was so nice. It's like int. Oh, maybe, yeah, this is correct now. Yeah, I had to pass more than 3 guys, so this guy kept going below 0. Yeah, okay, I got it. This is gonna fix it. Okay, perfect. Now, maybe we should do like more than 0. No, not really. I don't know, I wanted to pass 2 for this guy because I wanted 2 numbers. Yeah. Yeah, this is correct. Then everyone gets 1 number. So 1, 1, in the game, the score. Well, the score, just for fun, I could add like 4. Yeah. Okay. But we can get greater than that, but that's just for fun. Okay. Now, so this guy should be just greater than 0. Yeah. Perfect. Now, in our console, okay, I'm going to draw both of them, the hole and the frac. And I'm also going to draw like a point. So this is going to be like, well, I have to offset a P. So we draw the frac. We have to move left a certain amount, and we don't know what amount. Maybe the draw number passes like the x offset. Yeah, the px. Let's do that. Okay, so we moved left. Now I should draw a point, like draw a rect. And I'm going to draw like maybe at a P. Well, let's make a sub v2 P. And I'm going to subtract that with a v2 of 0. Let's do 2. My voice is really starting to fail me now. It's been like 3.5 hours. Yeah, it's getting kind of late. And then we're going to do a like 0.5, 0.5. Okay. And then we offset the P a little bit, like 1. I don't know. Let's see. We have. This is like super wrong. Yeah, well, save like original x. Here I do like p equals v2. Well, I just do like p dot x equals original x. Okay, now these guys are really crazy. Like, I should really add more like 1. Then I can move like by 3. So I do like 1.5. Actually, oh, that was too much. Let's do like 0.75, and we do like 1.5. Okay. Better, but not quite. Let's do -1, and then here we do like -5, and then let's do like add. Okay, the x is wrong. We should do like plus this guy. Well, maybe. Okay, now this is way too big. Let's do like 0.2. Okay, starting to look decent. 0.25. Okay, I can live with that. Well, I think our points are wrong. Let's do like let's do this one. Yeah, the point is wrong. We should really subtract 2. It was correct. Maybe 2 was too much. Yeah, it is too much. Let's try 1. Okay, that looks perfect. We got 0.65, which is nice. I'm not going to round that. I'm just going to end up. So let's again, but let's do like slowly. Okay, yeah, now we can. Oh, should have deleted the whole thing. Just this part. 0.05. Okay. Yeah. Well, let's start out with 0. Shall we? Okay. This is pretty cool. I'm happy with that. So today we did a lot of stuff. A lot. We saw like a lot of bugs. We did bitmaps. We drew the bitmaps and implemented them. We did, I'm not going to try to remember. We did so much. The game is starting to get pretty cool. Well, didn't compile that, I suppose. The game is starting to get like really, really cool. And our engine, our rendering engine, in terms of feature, I'm going to say that it's now complete, feature complete. We don't need any more rendering stuff. But what we do need, in case you haven't noticed, is audio. We have no audio, and our engine doesn't support audio yet. That is next stream's goal, to implement audio. So I do have to come up with some audio for us to play. Maybe I'll just play like last game's music until I can get nice music going on. Yeah, maybe I'll do that. So we're going to implement audio next time, and then we're going to do threading the other time. Yeah. Maybe 30 was too much, too like 35. Because if you move slowly, we shouldn't really feel that. But if you move like fast, yeah, then we can feel it. I think that's better. Okay. Thank you all for watching this stream. I had a lot of fun. Today was like a very productive day. These 3.5 hours. If you want to download the game and play not only the game, but play around the source code for free, you can do so on itch.io. You can go to danzedan.itch.io, and then you can just download that. You're welcome to give me a tip, but if you don't want to, just take me to download, and then you can download all these files. You can choose which episode you want to watch, you want to download and play around with the source code, because we've been streaming this whole thing. All 10 episodes now are on YouTube. And you can see from the very first line of file that we wrote all the way to what we have now. And the YouTube is youtube.com/danzedan. So that's it for today. I hope you enjoyed it as much as I did. And I hope to see you next time we're going to implement audio. That's going to be really successful, I think. Let's see our bitmaps. Well, if our render, oh yeah, we also did like random seed. If our render help us, if our random guy, okay, see bitmaps, perfect. That is just perfect. Strong blocks. Ugh, crap, got strong blocks. Okay, so that's it for me. Thank you for watching, and see you guys next time.